Okay, hello everyone. I hope that you can hear me. I can't see.
Yes, we can hear you and can see.
Okay, good. And I hope that Paolo is here as well. Okay, hi Paolo, hi. I can see that you're here, you're muted, but I hope that you can unmute yourself.
Yeah, perfect.
Good. It's a great pity that you are not in the sunshine of Moscow.
No.
At the moment. So I am also not in the sunshine of Moscow. I am still in the sunshine of Great Britain. So this is at least the weather is reasonable.
Actually, today in Spain is cloudy, so that's why you have the sunshine.
Right. Okay.
Oh, nice to see you here. It's Vladimir. Hey. So I think that Serge will be the best person to present you to our audience. So it's for him to begin.
Right. Okay. I hope that people are gathering. I can see that there are 46 participants at the moment, and my understanding is there will be more. And I will start slowly by telling. So, actually, whatever I say needs to be taken with. So whatever I say, I need to be very careful because Paolo is probably the best person in the world to assess the personality of any producer of text. Right? So this is what I enjoy in.
This is
in
a fake news. I'm not the best one.
I have been.
I detected the fake news. You see.
I have been looking into what you have been producing for the past 15 years, because there is a kind of interaction between what I do and what you do, because we both are interested in looking into the stylistic properties of a text, right? I am quite interested in genre and in author attribution. Right, but then an extension of genre and author attribution is to look into the personal profile of the reader, and the work Paolo has done over the years in predicting various properties of the author. They are quite interesting. And the other thing which is also relevant to the idea behind dialogue, because the reason why this conference is called Dialog, it's not because it is about building dialogue systems. It is about the dialogue between computational people and people in linguistics. And Paolo is actually a very good example of using, so then over the years, from what I noticed, you have been using quite a lot of linguistic features in order to predict properties, right? And this what makes your work a bit different from many other people who work in the field. And on top of this, so then Paolo also mentioned quite relevantly the work of so fake news, right? So I think that this is definitely true, that you have the tools for predicting the profile of a text producer, right, or of a speech producer. But now also you started working on fake news and on hate news, on hate speech. And this is an area of great, on the one hand, this is an area of great concern for all of us, because the proliferation of both hate speech and fake news on the web, especially in the context of the ongoing COVID, but also in other areas, in politics, in everyday life, and in advertising, etc. So this is definitely a great problem in the society. But linguistically speaking, this is also something which is very interesting, because you have news and you have fake news, and some people fall for fake news. And what makes them falling for fake news, this is not clear to me, right? Because I think that I can spot fake news when it is fake, but then, and my feeling is that practically everyone can do this, but they don't. And this makes this phenomenon quite interesting, and I would like to see its investigation, and I'm very much looking forward to seeing your presentation here today. Right. So that's a brief introduction into the topic of what Paolo wanted to make. And Paolo, now the floor is yours. So we have overall 1 hour in total, and the expectation is that you will be spending something like 45 minutes on the presentation, and we will have 15 minutes for questions. And I will also so then there are various ways of doing this in Zoom, of alerting the speaker that the speaker is getting out of time. My preference is actually to write a note on the screen, right? So then because if I am co-host, I can write a note on the shared screen, and this will be just a scratch. So if you see a scratch on the screen, and then you will be able to see the screen, obviously, then this is an indication that I want. So then actually 3 scratches is 5 minutes to go, 2 scratches is 1 minute to go, and a single scratch is that it's time to actually to change lanes. I'm following the indications on the motorway, right? So then 3, 2, 1, and then this is where you need to exit the motorway, right? Okay.
Okay, spasiba, Sergey, for the introduction. And you said that I'm the best of the world. So actually you can read on the back, Paolo, King of the Bongo. This was a gift by a PhD student of mine. I don't know if he meant to be ironic, because one of the topics I have been also working on is irony detection. But in this case, I wasn't so good myself to detect the irony there. Hopefully he wasn't so ironic. Anyway, trying to get serious. Okay, I'll try to share let's see. Come on, yeah, right.
I think you
okay, I guess you can see my slides, no problem now.
Yes, I can. Yeah, thank you.
Great. So maybe if I don't know, I can hear me with echo. So someone maybe has the mic open, switch on. Right. So this is what I would like to share with you in this approximately 45 minutes. Well, I will be sharing what we have been working on the detection of fake news, conspiracy theories. As Sergey said, I'm a full professor here at the Universidad Politecnica of Valencia, but I also collaborate with Olesia Kolshnova as academic advisor at HSE. Right, so before, just to clarify some differences between terminology, misinformation and disinformation. Nowadays, what is fashionable, everybody talks about fake news, but probably we shouldn't do it, because fake news is not fake from the beginning till the end. It's actually based on truthful information, and that where it is embedded some false information. So what the experts suggest to talk is about misinformation and disinformation. So we'll see, we'll clarify what is the difference. Then I will share with you something that has been done and we have started doing with respect to credibility detection on Twitter, concretely. The importance of incorporating in the approaches effective information. Because I mean, fake news, well, I just said that we shouldn't use fake news, but at the end of the story, this is the brand, you know, name everybody uses, because a fake news wants to, I mean, a fake news wants to trigger some emotion in the reader. So that's why it's important to take into account this information. Then I will say also something we have done with respect to approaching the problem not only taking into account the textual information, but also, for instance, images. So to approach the problem from a multimodal perspective. And I will finish saying also something about the importance to profile the source, in the sense of profile the person who, I mean, sent certain information, in order to have an idea if this person had, for instance, in the past already propagated some fake news or even conspiracy theories. Right, misinformation, disinformation, false information in general has been always there in the past. And so what's the difference? Well, between the two. If false information has been shared, like it happened by Orson Welles when he read on the radio about that we were invaded by aliens. So if the intention is not really to hurt someone, like the case of Orson Welles, okay, I mean, even if someone actually in the end could believe that this is true, we should talk about the misinformation. If instead, like in the first example there, I mean, something about the health, for instance, of King George II, they said in order to destabilize the establishment, so in order to really harm someone, then we should talk about disinformation. The difference is that, of course, now with a click, because of the internet, the propagation of this misinformation and the disinformation is faster. So also in the case of misinformation, where there isn't the intent to really harm someone, of course, I mean, if so many people receive this information, still a good number could believe that actually is true information, truthful information. But this happened, for instance, in the case of satirical news. There is a web page, The Onions, where, you know, satirical news about especially politics are written. So people who know about this site, I mean, know that this news shouldn't be taken into account literally, but they are mostly satirical. But it happened that actually a few people believe in literally what was said in some of this news. Different if instead, I mean, there is an intention, as I said, like in the case of Macron here. Let's talk about some, you know, politician that is neutral to you and to me. Easier, I mean, like Macron. So basically, there was a duplicated version of the Belgian newspaper Le Soir, and just before the French presidential election in 2017, and there was an article saying that claiming that Macron was founded by Saudi Arabia, had an offshore bank account in the Bahamas, and so on and so forth. So in this case, it's not just that, I mean, to be satirical, of course, the aim was to hurt, to somehow have an impact on the French presidential election. So in this case, we should talk about this information. And yes, as it was already said, I mean, by Sergey, in this period of, you know, of COVID-19 pandemic, actually we talk often about infodemics because so many are rumors, conspiracy theories about vaccine and so on and so forth. I mean, everybody, for instance, could remember what the former president of US, Donald Trump, said that ingesting disinfectants actually was a good way to treat, I mean, coronavirus. And actually, I mean, this provoked some health problem and some death in some countries. Right. So why is it so difficult? What did I do? Okay. Why is it so difficult to detect in general, I mean, deceptive information? false information? Well, there are studies that humans, only approximately as a maximum 60% of the case are able to, detect deceptive information. Okay, there are studies done with 1,000 participants, for instance, and in over 100 experiments. So why is this so difficult? Well, because we can have, let's say, sometimes a peer pressure, so what is called a bandwagon effect, and so we could be influenced by the way we behave and we perceive the information we receive. Also, because of the validity effect. So if there are studies that say that if individuals, are exposed repeated times to fake information, to fake news, at the end, because they are tired, who knows, they believe what they listen, many times. And no matter if later maybe it is said that is fake, still many people believe is true. Then also because of the confirmation bias. So if we believe in something and we receive information that is somehow in line with our beliefs, we unfortunately have the tendency not to double check the veracity of the information, because immediately we could say, oh, you see, this is what I always say. And also because of the desirability bias. So if we receive information that somehow we like, we have we have a lower tendency to double check its veracity. There was a very interesting, very important work by Vosughi and colleagues that was published in Science 3 years ago about how false information spreads faster, much faster than truthful information. And so they carry out some experiments. So the study was based on rumors on Twitter. And basically they, moreover, apart from that usually false information spreads 6 or 7 times faster than truthful information. They also highlighted that false information usually triggers different emotions with respect to rumors that at the end are truthful, contain truthful information. So basically, false information triggers emotions like fear, disgust, and surprise. Okay, so this is actually important, and of course, many people work with Twitter data already before. This is, pretty famous work by Castillo and colleagues in 2011 already, and they basically monitor Twitter. And in the case of detecting a certain burst in the frequency of a set of keywords found in messages. So basically they collected tweets, during 2 days windows centered on these peaks. They collected approximately 2,500 topics, and they labeled these tweets as containing credible information or not, and they carry out some experiments with we are talking about the pre-deep learning era. So they employ a decision tree classifier, and they represented these tweets in terms of certain features that wanted to cover, information about the tweets themselves, so the message, the Twitter length, the sentiments, the usage of special characters, or also user-based features, so registration of the account, the number of followers, followees, and so on. Topic-based features, just to mention some of them: the fraction of a sentiment, positive sentiment tweets, and fraction of tweets containing URLs, etc. And also some features that try to capture somehow certain information with respect to the propagation. Their propagation, in the sense the depth of a retweet message, the number of initial tweets about the topic, and so on and so forth. So they carry out some experiments, and they were able to obtain an F measure pretty high, or nearly 0.9. We also, a few years later, actually, wanted to approach this problem of information credibility on Twitter, but taking into account these insights by Basughi et al., this paper I mentioned that was published in Science. So of course, I mean, a couple of years we were in the, deep learning era, we are still. So we approached the problem using LSTM. And we wanted not just using a deep learning based architecture, but incorporating somehow these emotional signals in the architecture of the models. We carry out some experiments with the claims from PolitiFact, so a website where claims are are classified, are labeled as, truthful or not. And we incorporated these emotional signals on the basis of emotional lexicon, on the or also in another variant, including considering the intensity of the emotions, or via a pre-trained deep learning model in order to somehow infer the reaction that a user could have because of what this pre-trained model learned with respect to emotional reaction on the basis of previous text. Yeah, well, maybe it's not the case to enter into details, but yes, saying that, for instance, with respect to the pre-trained LSTM-based model, 3 intensity levels were considered: low, average, and high, and the 5 reactions like love, joy, surprise, sadness, and anger were considered. Okay, so we can see, what we wanted to do was comparing the results with these 3 variants, that we consider in our EmoCred architecture. So considering just the emotional lexicon, or emotional lexicon plus the intensity of the emotions, or the pre-trained deep learning model. We wanted to compare these 3 variants with the LSTM that receive just textual information. And what we can see in actually the 2 data sets we built from PolitiFact, that even if not exactly the same variant in both cases obtained the best results, but yes, the takeaway message is that incorporating emotional signals allow to obtain better results if just textual information was considered. In another work with a former PhD student, we approached the problem, but in a slightly different way. In this case, we didn't apart from Twitter, we consider news article. And this data were labeled with one of the categories that refer to so truthful information, real news, or satirical information, propaganda, clickbait, hoaxes. And so, I mean, the granularity in this case was a little bit, finer. And even if the approach was slightly different, once more, yes, we consider a STM-based approach. So the textual information once more was passed via word embeddings to the STM, but the emotional signals were taken into account and integrated later in a dense layer, but in this case using different lexicons like the ones you see on the slide. So Emolex, Emosentinex, Sentisense, Enfath, and Luke. So in the two cases, once more, we wanted to compare this model with the LSTM with just the textual information and with other baseline. And in both cases, the takeaway message is that once more, it was possible to obtain a boost in the performance of the model. Right, then multimodal fake news detection. So what we wanted to do was to see if incorporating also the information of images could somehow help in the detection of fake news. We carry out experiments with 3 data sets, but the main idea, pretty simple, was that from one hand, we process the textual information via word embeddings, like a word-to-vec, for instance. Well, in this case, we consider also the sentiment information of the text. But the main point is, okay, textual information via word embeddings. On the other hand, the image was processed thanks to, in this case, 5 pre-trained models. Models that were pre-trained on a big image data set, ImageNet. And so basically, for each model was able to infer the most likely tags that could somehow describe the semantics of the picture, so what the image is about. And we consider 10 for each of these pre-trained models, BGG16, 19, ResNet, and so on. And then we calculated the similarity between what? These tags and the textual information of the word embeddings. So this was done with a simple similarity measure based on the cosine between these two texts, the word embeddings and the tags of each provided by each pre-trained model. Plus, we use some, we also consider some visual features like local binary patterns, but actually the most interesting part is the one I just described. Then all these features were passed to a classifier. In this case, a neural network was used. So, of course, we wanted to see if actually considering the visual information help, not only the visual information that was extracted via the tags that describe the semantics of the image, but also the similarity of these tags with respect to the textual information contained in the word embedding. And yes, we can see that on the 3 collection, actually, this was the case. And even if, okay, we tried different combination of these features, so not exactly the same on the 3 data set, the same combination was the one that allow us to obtain the best results. So in one case, for instance, on the medieval data set, just to highlight it. I mean, the text of the tags themselves, I mean, it didn't help much, but what helped, no doubt, is that apart from the textual information, was important to consider this similarity between the tags that express what is in the picture and the textual information of the word embeddings. And of course, we wanted to compare just using the embeddings, the sentiment information, or just the similarity between the two and so on. And I mean, the best score was obtained, including considering, I mean, more information at the time of representing what is in the fake news. All right, in a follow-up work, we wanted to ask ourselves, okay, well, we just consider an image, but what about if the document actually contains more than one image? So we, yes, we said, well, let's try to consider more than one image, maybe 2, 3, 4, depending on the documents, of course, if it's possible. And in this case, we simplify a little bit the experiment scenario, in the sense that the text for the textual component, we just use BERT, so the bidirectional encoder representation from transformer by Google. And with respect to the visual component, we didn't use 5 pre-trained models. We use just one, VGG16. And then following VGG16, we obtain better results passing the information of the tags to LSTM. Then, yes, with respect to the similarity, so the semantic information and the similarity between the tags embedding and the textual embedding, once more, we use the cosine similarity. So basically, we had a similar, even if a slightly simplified architecture of the one I showed you before. So we have the textual information. In this case, we just focus on the title. Then more than one image, and in the picture you see there are 3, because actually the best results, we obtained the best results when it was possible, of course, with 3 images. And then this similarity between the title and the tags, and was also considered. And once more, I mean, all these features were passed later to a multi-layer perceptron. Without entering into much details, what we can appreciate, or what we could see ourselves, was, well, first of all, we wanted to see once more, I mean, the different, I mean, we carry out some ablation tests, in the sense that we wanted to see the results we could obtain, maybe without considering the similarity between the textual information and the tags, or considering a different number you see here of images. And also we wanted to compare ourselves, I mean, compare the best model with just a BERT that rely on textual information, or with 2 of the state-of-the-art models, spot fake and ENN model. And yes, indeed, the best results were obtained considering 3 images, and results that improve also the state-of-the-art models that carry out experiments on the same data set I mentioned before. So even if in some cases the improvement is not so high, was statistically significant, and so I mean, usually approaching the problem of detecting fake news from a multimodal perspective helps, or at least it doesn't hurt. Right, and the last, I would like to say something with respect to the role of users, in the sense, in this loop where, you know, fake news are created by someone and then sent around, so propagated. Of course, I mean, users, common users, us, play an important role in propagating even more this fake news or stopping their propagations. As I said, I mean, because of, for instance, the confirmation bias, we could be tempted to share immediately something we receive without double checking its veracity. And of course, this shouldn't be the case. So it's important to somehow having an idea about the credibility of the user we just receive information from. So we carry out the beginning very preliminary experiments considering accounts in Twitter that contain factual and non-factual information. Once more, we represented the text in Twitter in this case, considering a word embedding, in this case globe. We also consider other stylistic information, sentiment, emotion, and other categories that help in representing the content of these tweets, and we use, as we did previously, LSTM-based model. So basically we wanted to see if it was better to process these tweets one by one, or chunking, I mean, grouping tweets by the same authors and processing them. And actually, this is what the takeaway message, that even if the deep learning based technique, the LSTM based approach, wasn't able to obtain slightly higher, but not so better results in comparison to a simple, in between quotes, a logistic regression model. Maybe also because of the size of the data set that certainly could have an effect on the final results. Yes, we can appreciate that processing this information at outer levels allows to obtain better results in comparison to processing the information at the tweet level. So then we wanted to go a little bit further, in the sense that we wanted to try to discriminate between fake news spreaders and those users that actually fact check the information. So once more, we approach the problem using a deep learning based model, but in this case, the best results were obtained with a convolutional neural network. But we didn't want to just use a CNN on raw data. We wanted to incorporate, to have also apart from, of course, the textual component where the tweets are represented via word embeddings. We wanted also to have a psycholinguistic component where, also linguistic patterns and personality scores could be taken into account in order to merge later, this information in a dense layer before the final decision. Right, just to give you a flavor of what these linguistic patterns were, we rely on the Luke software that have basically 73 psychologically meaningful linguistic categories, like apart from pronouns, I don't know, categories about the affective processes like anxiety, or cognitive processes, or personal concern, and so on. And also we wanted, so remember, we are working now at the outer level. So given a number of tweets, we wanted to do what? To infer the personality of this author on the basis of the big 5 taxonomy. So openness to experience, conscientiousness, extraversion, agreeableness, and neuroticism. And this was possible because of former studies of Newman and colleagues, where for each of these traits, is a certain number of adjectives that was empirically proven that are used more by people with this, I mean, each of these trait. So for each of them, so was available. So basically we could compare the text written by an author and to see if contain you know, this specific, what specific subset of adjectives contain, and what we can appreciate in the results that are not very high because the task is not so easy. What we can appreciate that actually, as I said, the best results were obtained with a CNN in this case instead of LSTM, but a CNN that included, apart from the personality traits, also the Luke base, so the psycholinguistic patterns of Luke. We, in the same line, we organized a shared task last year at the PAN Evaluation Lab at Clay, where we provided the participants with authors in English and in Spanish. Half of them contain some of contains tweets with some fake news. And so for each author, we provided 100 tweets. And, you know, many have been the approaches. Of course, many rely on deep learning based models. And in many cases, with respect to features, few teams incorporated emotional and the personality features in line with what we also did. But I mean, no matter that these deep learning approaches usually help to obtain the best results, in the case the data set is big, but it's not big enough. Sometimes the very best results are obtained to classical machine learning approaches, like an ensemble of a logistic regression in one case. With respect to English and an SVM, support vector machine, about on the Spanish data, and where text, where tweets were represented with, I mean, taking into account the stylistic features, anagrams of words and characters. And finally, in the 5 minutes maybe I have left, or maybe less, I would like also to share with you what we tried to do recently. So to see if it's possible to a certain extent to profile those users that are conspiracy theory propagators. Like I mean, that they believe, for instance, that the Earth is flat, as we all know, and other things. Right, so the way we proceeded was to rely on some hashtags in order to retrieve tweets that contain them. So hashtags used by the pro-conspiracy people, like, you know, anti-vax, of course, talking about what we are living in the last 1.5 years, you know, flat Earth, NASA's fake, so we never, moon landing fake, etc., etc. And instead, with respect to having also tweets, I mean, authors that wrote tweets that authors that were anti-conspiracy. So we rely on other hashtags that they mainly employed, like NASA is real, climate change is real, Earth is not flat, vaccines work, and so on and so forth. So we came up with approximately balanced data set of nearly less 1,000 authors per category. And what maybe in just a couple of minutes I could highlight is something logical. If we think twice, it's logical that the propagators have less followers than anti-conspiracy propagators. Well, concretely in these data sets, they had 9 times less followers because usually their accounts are newer, and so they have less followers. Something also to highlight is that usually conspiracy theory propagators, even if I mean these differences are not very high, have a different personality. They are more introverted, for instance, with respect to non-propagators. And yes, I mean, they are less agreeable, they lower score in agreeableness, as you can imagine, because if you don't believe in their conspiracy theory, I mean, they usually then try to use a more direct and aggressive language. And actually, this is what we notice also. They tend to use more swear words. If you are not aligned with their theories. And what we also notice, they use more words related to religion. And actually, if you remember about the march to the Capitol, I mean, when Donald Trump was still there, I mean, many people that, yes, believe that there was a conspiracy theory because they believe that Donald Trump actually won also the last election. They say that Donald Trump was there sent by God. So a lot of words were related to religion, actually. And last, of course, it wasn't only a matter to provide a data set, and it was also a matter to carry out some experiments. And this is what we did once more. And once more, apart from a deep learning approach, we wanted to incorporate some linguistic or personality features. And this is what we did. In this case, the best results were obtained with a CNN-based model, and concretely that rely on that had also psycholinguistic features that we extracted from Luke. So this is basically what I try to share with you, and this is the end. So basically the takeaway messages are, you know, it's important to take into account emotions in our model, also linguistic and personality features, not only, I mean, just a deep learning approach that works with raw data, but also these features can help. Relying on also on visual information could help. So having a multimodal approach to the problem is doesn't hurt, as I said previously. And it's also important to know something about the source. The source, if there is a URL, of course, we can know about how much reliable this source could be. But in the case of receiving an information by a user, yes, makes sense to profile this user to see if in the past the user, I mean, had the tendency to share fake news or conspiracy theory. Something I didn't mention because actually we didn't work. We usually don't work so much with networks. We don't approach the problems that take into account the networks. So analyzing the networks, I didn't mention this, but certainly something that in the loop should be also taken into account. This year, we are focusing at PAN on the other side of the coin, and usually people refer to harmful information, so harmful in the sense that there could be fake news or conspiracy theory that we have seen that they could have certain damage effects on people. but also, I mean, hate speech. We have seen that, for instance, the usage of aggressive language, swear words towards those people that don't believe in conspiracy theory actually is there. And this is what we organized the shared task at PAN about this year. So profiling haters in Twitter. And this is the end. Spasibo for your attention. If you have any question or, curiosity or suggestions, yes, suggestions, very important. You are more than welcome. Thanks.
Okay. Thank you very much, Paolo. Actually, this is bang on time from the viewpoint of chairing, and it was quite interesting. Lots of thoughts for research. We also have a number of questions in the chat. I think that the questions I will separate them into two parts. One technical and another one is more societal questions, right? So the two technical questions. One question is about the transformer models not included in the baseline in your in one part of your talk, right? So then you included them, and then in some other studies again you didn't include transformers, even
Correct.
though it was after the start of the BERT era. So what's your actually feeling about?
Yes, you're right. Good point.
Else?
Yeah, good point. Actually, in most of the cases, we carry out experiments on data sets that other colleagues previously used. And so the best results, at least they weren't reported using transformers. They use LSTM or CNN. So this is what we did. But yes, in order to make things more complete, yes, now a posteriori we should carry out some experiments also with Bert, Roberta, and okay, now there is a big family there waiting for, carrying out some further experiments. So yes, a good point. You are right.
Yeah. So actually, then I would like to extend this a little bit more because not so then BERT is not everything.
Yeah.
And I noticed that in your latest experiments, you used CNN instead of BERT, and then this was in 2020. So probably so then you do have the feeling that for some kinds of studies, using BERT rather than other tools is beneficial.
Maybe we were biased ourselves by the fact that the previous year we carry out experiments with a CNN-based model in order to profile fake news spreaders. So we wanted to see if a similar model, so a CNN-based model incorporating some psycholinguistic and personality information and so on, could help also to profile conspiracy theory propagators. So yeah, probably that's why we didn't consider just to compare also with a BERT, but yes, we should have done it, and it should be done. Just for curiosity, not a BERT, but all the family.
Good, thanks. And then this is related to another question on what you can get out of the text and what is beyond the text, right? So then one example is that when you use an emotional lexicon, for example, for prediction, then you make prediction out of the text. So then if someone says disgusting, then this reflects one kind of emotion. When someone says fantastic, that's another emotion. But at the same time, if you have Donald Trump telling us that that using disinfectant can help curing COVID, right? This is a very factual statement which causes outrage, okay? And so there is nothing from the lexicon there. And because of this, I think that, and this is my opinion, but please elaborate on this, then a model which is based on BERT is much better in predicting what is the likely reaction can be, in comparison to a model which is based on the lexicon, which thinks that a model which is based on the lexicon thinks that words like disgusting or fantastic, they are more likely to reflect the emotion.
Yes, I mean, I don't want to say that in all cases incorporating affective information or taking into account information that we could see in images could help, but on average, I mean, seems to help. And actually related to this, yes, I forgot to include it, but okay, I can mention. I forgot to include this slide. Recently, we had a paper published at the EICL where these former PhD students actually show that, especially at the beginning of a document, is when I mean the fake news spreader, let's say, is aims to grab our attention. So is where words, for instance, like in titles, but not necessarily only in titles, also in the first paragraph, words that trigger emotion of fear, surprise, fear, and disgust. Are used, and so I mean in many cases this helps. This doesn't mean in all cases, of course.
I forgot unmuting my own mic. Right, there is another question. There is another question which is about the application of the of fake news detection. So do you think that neural fake news detection is robust enough to be used in real life scenarios? And in this, so then one of the adversarial uses of a tool like this is that fake news publishers can adapt and change their posts so that they can bypass such filters. So
this is the like the mouse and the cat and the mice play. I mean, of course, I mean, you improve the detector and then fake news, I mean, spreaders try to use other techniques. I think that, I mean, well, what we, of course, I mean, something that these automatic tools can somehow help to highlight that some documents could be potential, could contain potential false information, or I mean, sometimes contain false information because it's possible to immediately, I mean, I'm not saying in real time, but there are, you know, sites like PolitiFact, etc., that they publish some false information the next hours or so when it starts to be spread. And so, or because of that, or I mean, because I mean, it contains information, contains statements that cannot be proven, or they trigger a certain emotion. This doesn't mean, of course, necessarily that because of that it's false. But let's say what these tools should be, okay, or at least the way that, in my personal opinion, these tools should be used is just to, in terms of awareness, to let us know that there are some indicators that should make us aware that maybe these documents should be double check, we shouldn't believe 100% with respect to their content, and so on. Then, of course, there is a very important problem that is actually, I think, the first question I was made, that this is dependent of a political social order, because who is going to decide what is fake and what is not? Yes, I mean, I can talk about Spain. And for instance, there are a few sites. One is neutral, that neutral, but written in as a new, like news, tral, that should, I mean, they mean that they mean to be neutral, but so when they double check the veracity of information in news, but they are quite in line with the actual government. So there were, you know, there was a discussion about this. Okay, what they label as fake news is because potentially, I mean, it's not so much in line with the beliefs of the center left, well, the center left, yes, the government that we have at the moment. So yes, this is very subjective, and actually, to some extent, this could be misused, in the sense that something that could be labeled as fake news if it's not in line with some political interest. But I mean, as a computational linguist, we cannot, okay, we can have our opinions as a human beings, but we don't have the power to I mean, we don't have the voice to ask to use these tools in the proper way, let's say.
Great. Thanks, Paolo. Actually, we went into the range of questions which were asked about the societal implications. So then the questions about what is considered to be fake or not fake, and whether there is an introduction of censorship of some kind or the other. And also in this respect, it's also interesting. I'm not sure. Are you in touch with any of the platforms, such as Twitter or Facebook, when they do their policing, because they have quite large teams involved in natural language processing, and then one example is Roberta is a production of Facebook, right? And then they develop Roberta not only for the sake of us as computational linguistic community, but also for their own research and for application within Facebook. So I wonder whether you are in touch with any of them, either Twitter, Facebook, or any other platforms.
Yeah, well, no matter what you can read, that I'm the king of the bongo, but I'm not such a king. So in the sense that, okay, I know some people working there, but to be honest with you, I'm more in touch with Spanish sites like Neutral, Maldita, and yeah, so yeah, they apparently they try to be the more independent that they can. But this is what I know. Certainly, potentially, let's say that maybe in some countries more than others, but potentially everywhere, something that is not in line with you know, the beliefs of who is a ruling country could be considered, this is fake. I mean, so don't believe this automatically. So yeah, this is very, very sensitive. I cannot say anymore. I mean, there is nothing more we can do.
Yeah, that's
well, what we can do again is to try to provide, in my opinion, tools that don't say black and white, just they give some you know, information about what is not be possible to fact check. And so, I mean, then users should use should do their work to, I mean, not to believe everything they receive, but.
So, and this relates to yet another question, which has been asked, and this is my own question. It's about multilinguality, because you mentioned that you work with English data and Spanish data, and
Yeah.
obviously the sizes of the data sets available for English and Spanish, I believe they differ quite considerably. And then if you look into smaller languages, then probably you will have even less data.
Yeah,
So
for sure.
I wonder, what is your impression of the link between the size of the data set and the results you obtain?
Yeah, like sometimes people say it in jokes, but I don't want to say it, but yeah, size is important. And so English, yeah, the problem is that if you wanted to do some research, of course, on a topic, you needed to compare with what others did. And so majority of works are done with English data because more resources are available. So English, if you wanted to see if your approach somehow can improve the state-of-the-art results, is a must. Of course, I mean, I live in Spain, and I mean, we are funded by the Spanish Ministry of Science Innovation, so it's a must also to try, especially when we organize a shared task like the ones I mentioned at the PAN Evaluation Forum, is a must. I mean, we are not forced, but from an ethical viewpoint, this is the minimum we could do to try to provide a data set also in Spanish in order to, I mean, foster the research also on Spanish data. But yeah, there are yeah, I mean, there are less resources in general, and for other languages even less, of course. And so it's something that should be done. It's also true that we live in a global world, so I mean, we are all connected. So if there are some interest or global interest to share, to spread false information, fake news, this is done in English. Because if it is done in Swahili, with all respect for Swahili, okay, I mean, I receive an email in Swahili saying, oh, I mean, you'll get the new version, hopefully not, the new variant of a coronavirus. I don't understand it. So, I mean, English is a must, but of course, other languages, I mean, also should be in the loop.
But then in this case, it's interesting. So if you work with English and Spanish, and then there is clearly an impact of the size of the data set on performance. So in this case, do you see considerable differences in terms of the kinds of fake? So then there are probably two sides here. One is the difference in the society, right? So then the English-speaking society might differ, probably not that much from the Spanish-speaking, but then there are Spanish-speaking societies. And the other thing is also about the nature of language. I mean, that the lexicon. And then one simple example is that in the case of Russian, with lots of morphology, most of the time, even a data set of the same size is actually, it leads to worse results because of data sparsity. So then you have a word, and then this word has 27 different forms, and then this is not all covered in the data set. Actually, this problem is not as strong now with the rise of BERT models, because they do sub-word tokenization, and then they do detect something, but still this problem persists. So that these two sides, the difference between the societies and the difference between the languages.
Yeah, you're right. So what I can say, just to talk about the results we had in the shared task we organized last year. So we didn't see really a difference in between the two data sets in English and in Spanish. But it's also true that, well, for instance, with respect to the shared task we are organizing this year on profiling haters, actually we noticed, we didn't publish the final results yet, but we noticed that the majority of models obtain higher results on Spanish data. Of course, we needed to investigate further the reason why, but having a look at some of the samples, we had the impression that in the case of a speech, in Spanish, it was much more explicit, let's say, much more aggressive and much more explicit than in English. And to finish, of course, it's a cultural, not only language, but as you say, the cultural dependent problem, because taking into account, for instance, I mean, the possibility of incorporating in your model, you know, affective information. Certainly is a factor that in a culture like a Japanese, I'm talking about Japanese because I've been there doing an internship some years ago, and I'm certainly overgeneralizing a bit, so I apologize, but this is the impression I had being Italian, living in Spain, in comparison to Japanese. Let's say that they didn't express their feelings in the same explicit way that we, in most of the cases, we do around this part of the world. So certainly, I mean, it's not a matter only having the same resource in all the languages, but it's also a factor that probably certain approaches wouldn't work the same way with Japanese data, maybe because emotions could be more implicit and difficult to be detected.
Great. I think that we are nearly towards the end of the list of questions, but there is yet another question which I haven't asked yet in the chat. And then this question is: did the data set that was used for the author profiling task contain regular everyday life tweets or news as well? If the latter, how can we check that the network in fact learned to profile authors and not just map certain statements to be fake or true?
Okay, well, I can talk about, yes, the author profiling data sets we provide every year. Well, we try usually to, I mean, not to have tweets or at least not especially tweets containing news, because there isn't any stylistic aspects of the author itself. If you just share, I mean, title of a news, even if, okay, maybe for some task like profiling, I don't know, your political ideology could be helpful, but yeah, we try to use everyday, I mean, expressions. So that's why actually we try to work with Twitter. I know Twitter also is used to share, I mean, information about the news without any statement, any comments, any appreciation, but we try to minimize these tweets.
Great. Thank you very much. I think that this exhausted our list of questions, and now probably time for a short break. So thank you very much for coming here. And then the only person who can say thank you by applauding is myself.
Thank you.
So you're very welcome to stay for the rest of the conference. Many of the talks will be in English or with English subtitles, so that will be. I don't think that there will be many talks in Swahili.
Okay, so, that's good. That's good.
Okay, so thanks.
But also my knowledge of Russian is the same of Swahili. Okay, maybe a little bit better, but not so much. All right.
Okay.
Thanks
Grazie,
again.
See you. Bye. Bye.
Thanks.